What's up, everyone? How's it going? Happy Monday. Welcome back to a brand new Demystifying Post-Production Month. And I'm joined by two very special master trainers, Jonas and Noseman. How's it going, guys?
Great, thank you.
Hello, thank you.
Nice to see you
I'm
both.
great. And
Also, hey to everyone in the chat. So hey to Cause Design, Abduella, Brian, Paula, Mr. Simon Walker's in there as well, and Hannah. Nice to see you all. Thanks for joining us for this new month of December. Before we get into what we're going to be doing this month, and before I hand over to Noseman, I thought I'd do a little bit of housekeeping first of all. So if you ever want to see the events that we have going on, and this is everything from our live streams to events in person, like the DAT tour, you can just head over to this website here, and you can come down, you can see all the great stuff we have going on, all the great shows that we do as a team, and as I said, all of those live events that we have in person. And if you ever miss any of our shows or any of our streams, or you want to learn something new, then you can head over to this very special YouTube channel here, which is the Maxon Training Team. And everything we do gets recorded, gets put on there. We have everything from hands-on workshops to DPP, Ask the Trainer. You can also see all the upcoming live streams that we have going on. And courtesy of the amazing Dr. Sassy, these are also time-stamped. So you can always find a relevant thing throughout the maybe hours stream for you there. Also, on the topic of learning new things, you can head over to the lovely new Cineversity, where you can check out some Getting Started series. So maybe you've never tried ZBrush before. We have a great Getting Started series of ZBrush and all the other great tools. And if you are experienced and you fancy yourself a little bit of certification, then you can head over to the this site here on our maxon.net website, and you can try hands at the elementary knowledge test, as well as looking at the different types of Cinema 4D certification. And finally, as a big thank you for being part of our wonderful community, we love to give away free t-shirts. All you have to do is pay for the shipping, and all of the links for all of this stuff, including the password to get into this secret merch store, should now be in the chat. So yeah, grab yourselves a t-shirt and rep along with us lot. So a new month, guys, a new month at Noseman. Basically, I can hand it over to you now, because this is all you.
Oh, thank you.
All you, really, isn't it?
I'd be nothing without you guys. I'd be just the lonely master trainer showing great stuff on YouTube. I mean,
that's true.
But, it has to be stated that the majority of the stuff I show, I've stolen from someone else, including the people that are present now. So I can appropriate it. No one told me not to. And that's what happens when you're so generous with your knowledge, right? And no good deed goes unpunished. So thank you for that. I take full credit.
Absolutely. That's what we do.
There we go. That's how we roll in this team. We steal each other's ideas. Well, I steal everyone's ideas. I think that's enough.
Same.
Well, yeah, today we're going to talk about mechanical. Well, today and for the next 2 weeks, this one and another 2 weeks, a total of 3 weeks, we're going to talk about mechanical rigging. Now, there was a question on Twitter, and I have to make sure I address that. We're not going to show the simulation and the various bullet connectors and all that, because I think when I showed the front wheel suspension here, there was an impression that I'm going to show the dynamic links and all that. No. What we're doing here is we're going to show how you can go about rigging a robot and do that and setting it up and so forth. And what we're going to do, because this is an extremely open-ended subject, we can go on forever. We can spend the next of our foreseeable lives talking about this and learning new stuff. So what we're trying to do for these 3 weeks is distill it down to the most important fundamental knowledge upon which you can build and create much complex stuff. So this, for example, is sort of a simple mechanical rig. This is a recliner, which I sort of did, and it's based on a CAD model I found online. And we're going to focus on simplicity of things and divide and conquer. This is, I mean, I've got everything turned off here, not invisible So where have I hid everything in my layers? No. Where are all my joints? Oh yeah, it's the geometry only. So this is a bunch of joints that, everything is controlled by a single controller, and the spring is some sort of fake thing I'm doing with. How did I do that? I think I used a. How did I do that? Control. So let me move tool, control right click, and call a spring, press S. And what did I do here? Yeah, a spline wrap. Yeah. Something like this. And this is the stuff I'm going to show today, how certain types of mechanical rigging contraptions work. This is from a user I got, I think it was Ironsight, I think, if I'm not mistaken. I apologize if I, use other people's names and assign their work to other people. But this is, again, controlled by a single controller. It's supposed to be symmetrical and all that, but this is the main rig. And even this long time ago, I rigged this. So we're going to see the concepts which will allow you to do all these very defined motions. We may get into more complex stuff in the third week, where I'm going to attempt to rig some of these things from scratch. I could manage maybe 1, 2, 3, or as many as we can do. And yeah, I want to start with some very fundamental concepts. I'm going to talk about this in a moment. And what do we mean when we say mechanical rigging? And a very good example is the recliner assembly. And this is an assembly, first of all, that is plausible. So you can actually, this is apparently a CAD model of something that exists, because we can, if we rig things that don't have the right dimensions, things are going to go all over the place. And that is not some sort of limitation of our particular system. In order to do a complex mechanism like this, you need to make sure it doesn't lock up, or it doesn't have any mismeasured parts that create some sort of part of it to seize, because that's very easy. The way you can try certain things is, I'm going to give you a few examples of what would be something you cannot really rig. So if you take a triangle, if you make something out of a triangle, I'm going to make it very simple. So you take 3 pieces of metal, and I'm going to go and turn on my lines, and let's rotate this. So let's assume we put some bolts here, here, and here. This doesn't flex. A triangle doesn't flex. It's absolutely rigid. So if you think that you can make a triangular crane of sorts, and this looks like a hangman's thing. So if you try and move this so that all the parts are connected, it won't move, because this can't move in real life. You can use popsicle sticks to do these kind of experiments. So the number one thing you need to know when you're rigging something, especially a complex mechanism, something like this, for example, is for it to have a plausibility of being rigged, which means that if you do build it out of metal, when you move something, it moves the way you want it to. And that's why these mechanisms are so complex. That's because, if I hide and keep the geometry, that's why they have these levers here that allow you to, that constrain the motion a certain way and so forth. Because without this lever here and this lever or lever, these 2 levers here, this would do a totally different motion. So always be aware that if you're trying to rig something, that it can be rigged in real life. That's the number 1 rule. If it can't be rigged in real life, you probably have a hard time rigging it inside 3D software. And even if you find models on the internet, it doesn't mean that someone modeled something in the correct proportions.
So what you're actually saying is that rigging begins with the modeling, right?
Yes, to a great
and that's the
extent.
same for like any sort of rigs. That doesn't just apply to mechanical rigs. It also applies to character rigs and so on. But in this case, this is a very obvious one. If you set, or if you drill your holes in the wrong spots, it in some cases might just not be able to move.
It will do something different. It will do
Yes.
something different. And maybe that
Or
different
block
thing
itself,
is,
yeah.
or block itself, exactly. Seizing
Yeah.
up a mechanism is the easiest thing. The triangle is the best example. Whereas if you have 4 arms, then you can have a proper parallel rig that works properly, just like this: 1, 2, 3, and 4. This can rig, right? A trapezium can actually move, but a triangle can't. That's why they use triangles as the basis when they make trusses for roofs and buildings and all that. That's why they're triangular. They have 3 fixed points. And even if you use just 1 screw, it will not flex, it will not move. That's why you don't see in bridges a rectangular contraptions. There's always a diagonal here that creates 2 triangles that therefore makes it stiff. So understanding how the mechanical world works is the number one thing you need to be aware of. That it can. Now, let's talk about some other things that have to do with this. So let's assume you have this contraption here and you want to find the best starting point. This implies, because you can see that this object over here, this one over here, is a static one. It doesn't move. And that's by design. The person that created this recliner wanted this to be static and everything else. This is the footrest, as I guess, and this is where the pillow goes, and it does that little motion. But you do need to know if you have any fixed points. Now, in this particular case, because that helps you, otherwise, if this moved as well, then it would move in different directions. So make sure you know in your final, let's say, animation or whatever you're trying to do, that you know what the fixed points are, or define them, unless you're working with something like a scissors. A scissors does not have a fixed point. It can be moved by both axes. And we are going to do a scissors today, which illustrates the fundamental, simplest of all mechanical rigs possible. So once you've defined, and let me bring up, once you've defined which part of your model is fixed, you can see this object is not rigged because it won't move. But we have this one here and this one here, which are attached to it and do whatever it has to do. Everything else, and here is a preview of what we're going to see. This orange one, and you can see everything is a 2-joint setup. So this one has a fixed point and a point that moves. This one has a fixed point and a point that moves. Everything else is fixed on the moving points. That's why everything else moves. The only 2 points that are fixed here is this one and this one. Now, talking about fixed points, let's talk about the fundamentally simplest joint rig, which is you get a joint, you get a second joint, and you get a third joint. I've made 3 joints. You can always go to the joint tool, press Control, and draw a bunch of joints and do whatever you want. So let me remove that. We have 3 joints. So let's take one and put it up here. Let's take the other. And I'm actually going to move them together so we have some nice right angles. Not that I have to do that, but you know, OCD kicks in and I have to do things. Move 2 up, move 1 to the right. So we have 3 joints. The first question is, what is a joint? And the answer is, a joint is a glorified null. That's what it is. You can actually do the majority of these setups just by using normal objects, by making sure that where you're going to put the joint, if you were doing a joint setup, you just put the center of the axes. And I'm going to show you an example in a second. Then we need to create, once we've created our joints, we need to create a relationship. So let's call this 1, which is the base, 2, which is the middle, and 3, which is the end. I'm going to name it end for a very, very particular reason. And you need to structure your hierarchy by putting the end joint, which you're going to control with a null, as the last one. And there is a logic. I mean, you can always move them from both sides, as I'm going to show in a bit. But this is good practice to take the one that's going to move more and put it as the last joint. And the second good practice is to just add a null on top of the last one, just to move things around. And I name it root. Naming becomes very important, so make sure that you have the proper naming. The other thing about joints, if you select the joints, you will see that although they're glorified nulls, they give us some extra abilities. Some of them are useful for some functions. And in the particular case of mechanical rigging, we're not getting too many advantages other than, well, in this particular case, the visibility is what we want to do. Now, what you see drawn here is not the joint, and that's a misconception. The joint is this little circle here. So if we take it out, this is what it is. What is drawn is the bone, and the bone is just a visual representation of your hierarchy. We have 3 joints that create 2 bones. We have 2 levels of hierarchy. This one between 1 and 2, and this one which is between 2 and 3. The axis is where the joint is, and the end is where the next joint is. And if I select all 3 using my middle mouse button, and I set it to box, for example, I can change the size, so I can make them any color I want, and this will help me isolate my joints. Okay, and these are just visibility settings. Now, orientation is another thing, but it doesn't really matter in what we are going to do, where you can tell, first of all, which is going to be the orientation of your bone as the joint is connected, and you can align them. But again, in this particular case, I'm not going to deal with this. Now, one thing that Jonas said about character animation. With character animation, we have the ability to make characters with bendy limbs and joints that expand and contract. But with mechanical rigging, we want to constrict per joint more of the motion. And that's what makes the difference. And usually, a mechanical rig in each stage is going to work in a flat plane, in a 2-dimensional plane. That's how most things, robots, recliner assemblies, even car suspensions, they are just a combination. Where's my car suspension? Somewhere around here. Front wheel. This is just a combination of many 2-dimensional rigs. That's what they are. So let's go find where I was. I was somewhere. Where was I? Totally lost. There it is, in title 12. Always the last one. So now we have this very simple sort of crane or whatever. Go to the first joint and add from the rigging tags an IK tag. And here, just in the tag, put the end one where it says end, and then click on add goal. This will create a null. And I like to put it first, and let's make it into a circle. So what's this going to create is it's going to force the rotations of these 3 to become to resolve in a certain angle, that these are always rigid dimensions. So this doesn't grow longer or shorter, and this one as well. And this is basically inverse kinematics. So you can see, and it's always on a 2-dimensional plane. Now, this is something that you will have to notice. Despite where I move this, you can see they're all rotating, so they're always nice and flat between each other. And that will become quite important in some of the more complex rigs we're doing. So what this is doing is trying to find the best fitting plane for these to lie on. That's it. So this is the most basic of all rigs, which will become the fundamental rig I just undid a few times. And combining many of these will allow you to do any plausible mechanical rig that's 2-dimensional. And when I say 2-dimensional, we're talking about things like the recliner. This is a 2-dimensional rig, and that's why you can see that I can have my joint hierarchy on a different plane, but it's still parallel to the original one. Now, which parts of the rig move, and how do we move them? One is the end goal. The other one is the root, or this joint here. I'm just going to move the root. And it does exactly the opposite. And this rig is the fundamental and starting rig to make a pair of scissors. So let's take it to the next step and create, I think I have a pair of scissors here. And we're going to move from one pair of scissors all the way to this pair of scissors. This is what we are going to do today. This multi-grabber, which I've just put some geometry so to make it a bit more visible.
That's
With
cool.
these two controls, everything is controlled. Please go ahead, Jonas.
I just wanted to say that it's cool. I like it.
Oh, thank
Yeah.
you. So how do we go from the most fundamental, simple joint rig to this rig over here? And this is the first door. I assume that up to this point, we have three joints, we have three joints, we have these two bones, and we have the root and the end goal, right? How do we go to that complex thing just by starting from this? And let's begin. Let's go to a side view. I'm going to go to this view so I can have the Z this way for no apparent reason. And let's go randomly with a joint tool and create this simple joint chain. This is exactly what I did before, but without taking any measurements because I couldn't care less at this point. Now, you can always create an IK chain. You select these and you create the IK chain. And the only thing this does is all the things I did earlier, drop the end goal, the end joint and create a goal, but it does it automatically for me. So the lazy version of what I did earlier, and everything still works exactly the same. Now watch this, and this is the most important part. We all know that a pair of scissors, right? These are all pairs of scissors from the asset manager. They have the one side of the scissors. Let's go and find this one. I can remove everything else. 1, 2, 3, bye-bye. And I'm just going to ungroup everything so we don't have more than we need. We have the screw in the middle. I'm going to select these and connect objects and delete. And connect objects and delete. And we have the screw and these two blades here. And what we basically want to do is rotate one and the other and create that motion for the scissors to open and close. So the first thing we need to assess for this particular rig is where are those joints going to be? And those joints need to be where you're going to use, you can put them anywhere. It doesn't really matter. As long as it's easy for you to animate. It's the same as if you can put your finger over the scissors, right, and close it, or you can put your finger through the hole and close it, or put your finger right in the middle and get it jammed and scream. But it's up to you. The same thing applies to the actual controls, which brings me to the subject of a very important part before you start laying your first joint down is to decide how you want to control it. What the end user of this rig, which is the part of the whole rig they would prefer to move or rotate in order to do what they want to do. And in the case of the recliner here, this is just one way of putting it together. And I've used this point down here for whatever reason. I just chose to use it. You may choose to unfold this by rotating this one. Then you'll have to do a slightly different rig. But if you want to animate this by rotating this, you could do that. If you want to animate it by pulling this point, again, you can do that. But each rig is going to be very much different in how things are connected, depending on the part you want to choose to move. So the control of the rig is the thing that defines, after the shape of your object, how you're going to set up these the joints and everything else. In the particular case of the scissors, it's not too much of a problem because you have two moving parts. You have the top part and you have the bottom part, and that's it. So that's why it's the ideal one to do a setup like this. So how can we create the subsequent sort of scissors over here? And here's how we do it. I'm going to get a null. And actually, I'm going to create the null as a child of not this joint. Oh, yeah, of this joint. I'm going to change. So I'm going to press Shift and create a null. And this is going to be called bottom. And let's go and make it something. Let's make it into a sphere. And I'm going to move it out. There we go. I'm going to move it out. And for this joint, I'm going to Shift and create another null. This one, I'm going to make it into a cube. I'm going to move it this way and make it bigger. I'm just arbitrarily placing these. It doesn't really matter. Watch what happens. Now, these are children of the joints. So what happens when I move this? They come together. And that's because this one is assuming the rotation of this one here. So it looks odd, but if you think about what's going on, this joint, when it rotates, because this is at a certain distance from it, it's going to move with it. And the same will happen to the other one. So it doesn't really matter. You don't need a joint to extend all the way to where you want the geometry to be affected, because whatever you make as a child of this is going to retain that relationship. And even maybe nulls is not the best way to show it. Maybe you want to show it using some sort of cube. Let me go 220, and I'm going to make this child of this. I'm going to go and reset the position and the rotation. And of course, I messed up my dimensions here, which is something I do very often. There we go. Make this narrower, extend this out, and let's put this wherever we want. You can make it as long as you want. The scissors is still going to work. And you can take this one, you can put it here, you can zero out your coordinates like that. And now we have those double scissors. There you go. Let me turn on Girl Shading Lines, and you can see here's our scissors. So it doesn't matter what's the shape of your object. As far as I'm concerned, your scissors could have a shape like this.
I really like that because it's so flexible that you can really put it into a 3D character's hand and link these nulls to the controller of a thumb and, let's say, a middle finger or index finger, depending on which one you're using. And then if you animate these, the whole scissor thing would just do the right thing.
Exactly. And
right.
This was an excellent segue to show you that what happens if it goes sideways. Look at that. It's just the same thing. If you twist your hand when you're holding a scissors, the whole thing is going to turn. And that's because it's executing on a single plane. That's the fundamental way that a simple joint chain works. Okay. And you can see from this line that it doesn't matter what your shape is. It will follow the rotation of this thing. And because I've seen users, when they have odd shapes like these, to try and create some sort of multi-joint that follows this. No, you don't need to, because there's only one line that connects this to this, and it doesn't matter if it deviates. It's a straight line, and that's why all scissors work in the same way. What the shape of the scissors is does not matter in the mechanics of what you're building. Now that I talked about this, I'm going to undo a few times just to go to that. There you go. Whatever this pose is, I'm going to put the cubes down here, and this is a good opportunity to introduce another very important difference aspect of doing any kind of rigging, and that is constraints. Now, the great thing about constraints, which if you right click, you can find them in the rigging tag over here, the constraints, is that we can create relationships between objects in terms of their transform, not by directly, instead of by directly making them children, by making them, by using constraints to do that. And the reason why that's helpful is that you may get into a situation like this robot here, where you have a mix of geometry and joints. The problem with this is if for any reason you want to delete all the joints, you're going to have a problem. You first have to ungroup them, you need to find them, and everything is intertwined in this particular model. You have controller nulls and joints and geometry all together. And for this particular case, that's what I wanted to do, because I never do things because of errors or omissions. I do things because I want to show something. And of course, that's all a lie. Let me show you now how you would use constraints to do this. So this cube here needs to be constrained to this joint here. I'm going to add a constraint. So the question is, okay, what kind of constraint? Well, we have many types of constraints that can actually do the same or similar things that have a lot of overlap. For this one, I'm going to use a parent constraint, which most people associate it with, using character animation and handing objects from one limb to another, or from one person to another. But essentially what this does, it internally parents the object to whatever you select. So I'm going to go with my eyedropper and hover over here and put it here. It records all the offsets and all that. I'm going to go to the other one. I'm going to add another constraint. I'm going to set that to parent. I'm going to click on this and select this joint. In theory, this would work exactly the same way without actually having the geometry parented with your actual joints. And that is a very efficient way of doing things. So what is the end goal of this? I'm going to remove the cubes just to avoid visual clutter and create that multi-scissory thingy madoodle thing. All right. So let's go back to these two joints, press shift and add a couple of, oh, I had to press another button to create another null, didn't I? So select these, I think control shift. Yay, it's control shift. Oh, it makes it a parent. I should do these one by one. So I'm going to press shift to create a null here and shift to create another null here. I'm going to pull this that way. There you go. I'm going to pull this way, and I'm going to pull this that way. Right? Remember our original scissory thingy-madoodly. Make them both cubes, put them here. I'm going to take the whole thing. So I'm going to call this scissors 01. Put the whole thing under a null, just because I want to be able to move it. I'm going to make a copy of this and put it approximately there, approximately. Emphasis on the word approximately. So what do I want to do in this particular case? Well, if I want everything to be controlled, and this is the second one, this is the one on the right, and this is the one on the left. If I want everything to be controlled by this, then what I need to do is bind the root of this one to this null, and the controller to this null. That's all I need to do. Nothing else. Or make them children, but that's what will create that mayhem. So I'm going to do it using using constraints. So let me bring this up. Why did I close the rigging tags? I always use these. I'm going to get an IK, and there are certain tricks you can do with IK. You can press Shift-C to bring up your commander, and if you type something constraint, it adds, this is a command, and this will actually constrain the two selected objects, the first one to the second one. So if I want to do that parenting as I did earlier, I can do it pretty much directly. But now I'm going to do it indirectly. I'm going to tell this joint here to have a transform constraint, and I want it to target, right? We are on this point here. I want it to target this little null here. So let's go here and target that. And it's, ooh, it popped. I think I selected the wrong thing. Yeah, that's got to, yeah, I selected itself. Joint 1. So let me do that again. There we go. I selected itself. What you saw is a very good example of a feedback loop. I told it, why don't you constrain to yourself, right? And of course, that creates a lot of cognitive dissonance and all that kind of stuff. Now, if you move this, you'll see at least half of it is going to move. So let's undo. And that was an excellent way to show what needs to be done. I can copy this here. It's going to break it, but then I can say, well, replace it with this one. Right? Now it flipped. And this is another example of why you need to make sure that there are certain types. You can see that you can flip a joint around. So maybe I shouldn't have allowed it to go to this state beforehand. So let's just open it, move it out of the way, and add a new constraint. One thing you need to be very, very careful with is undos. Always make sure when you get to a state of your scene where you've done a few things, save it just to make sure you can go back to this state, because flipping of joints doesn't get recorded because it's not an action you did. It's a result of an action that happened. So let's go back here. Let's put a constraint over here. Let's say it's a transform constraint, and let's select this little guy. Oh, it flipped. Okay, I'm going to show you how to fix that, because apparently that's how it wants it to go. Now they're moving properly, but we're having the issue with where this is going to be pointing towards. And this may have to do with the axes, but there is a particular solution you can apply. If you go to the IK tag, there's what's called a pole vector. And this is something that will force the middle joint, the one in the middle, to be in a certain direction. You can turn this around without putting a pole object. Turn it in the degree you think is required to bring it to that plane. And the reason is, I have a very good example of this, and that is my recliner double trapezium. This is it. Now, that's why you see these purple lines. These are the pole vectors. You can see that when I move this, they always go upwards. They always go upwards, okay? This one, sorry, outwards. And that's because I'm actually telling it to do that. If I don't tell it to do that, so I'm going to go and say, I don't have any pole vectors here, so let's clear all this. The problem is that it can find a solution whether they are in one way or another way. Now it doesn't want to do that, of course, because that's how I said it. But there's a plausible case where this will come inwards. And if you take it from a mechanical point of view, this is going to happen if you make this and the gravity pulls us down. Instead of folding upwards, it's going to fold downwards. The way they fix these is usually with springs or stop it before it becomes fully extended. But here, at least the joint is trying to go to its original position. If I revert to save this, yes, if I wanted them to go in the opposite direction, I would take there you go. So now I have the ability to very clearly tell it where I want it to fold. So that's another extra control you can add in what you're doing. And that's why I went to that over here. I just said, you're flipping the other way around. I can't bother to explain why this is happening. So just twist it so it goes in the correct direction. So as far as the first two, they're working fine. If I take the root, does this. This is exactly how a multi-scissors mechanism is supposed to work. And you can string as many of these as you want just by making sure that the control point, which is joint for one, the joint goal for one, and the root for the other, is located or constrained to the null that's in the appropriate position. You can take this, you can make another copy, you can move it over here, of course, because everything is now locked. It didn't move anything this way. And all we have to do is just go and change these to the appropriate point. So go here and where is this? This is the bottom one. I need to constrain it here. So this one needs to be constrained here. And this one needs to be constrained here. And again, let's go back to this and turn it back the other way around to 90 degrees. And I don't even know if this is going to work now, but oh yeah, because I didn't pin the right one. Did I pin the right one to the right place? Yeah, I pinned it on itself again. I keep doing this. So I think I need to pin it here. And let's rotate this appropriately. There it is. Let's see if this is going to work, or did I break it again? No, it's working.
It's really cool because what we see here is that even when you adjust the length of the parts, you can even create a scissor that would go like in a circle, for example.
Yes,
that's quite interesting. Yeah, because I used to rig this case purely using XPRESSO and with trigonometry node, which works as well, but it would only work in a straight way.
Yep,
like straight up, straight to the side or so. That's what I like about this one, that it's more flexible than that. But it also shows that if you want to use this approach and go and you wanted to unfold in a 100% straight way, then you would have to be 100% precise with your joint placements when you start creating the thing.
So you would go, you create a joint.
using snapping for it then, yeah?
Yeah, snapping, exactly, or quantizing. So you just need to make sure that the distance between the two is the same. That's all you need to do. And put this anywhere you want. It's going to create an X. Just make sure that it's 0 here, I'm going to say 100 here, or anywhere you want. But you need to make sure that the next point up here is the same distance of this over here.
Exactly.
And it's the same as I said in the beginning, that it needs to be, you can make a scissors that's not very, scissors would always be symmetrical because you're only moving either the top or the bottom. But if you're doing one of these multi-scissors things and one of your X's is smaller than the other one, then you have a mechanical problem because you can't extend it beyond, a smaller scissors only opens a certain amount, where a bigger scissors opens by a larger amount, although the angles are similar. But in any case, the demonstration here is that when you're creating a complex assembly or a complex mechanical rig, you can actually do a lot of things just by combining many of these scissor rigs. And again, I show it all the time because the recliner assembly, as complex as it looks, it's nothing more than 1, 2, 3, 4 of these 3 joint setups. That's it. And it's just that the one that I've chosen to be the mover, this one down here, then everything else is driven by those specific positions. That's it. Nothing else. I've animated this. This then resolves this one. This one then, with this point fixed, resolves this one. So this part is done. And then we have the extension, a null here and a null here, which control this one, and that's it. And again, this particular assembly, this is not the only way you can do it. And again, it's one of those things where if you have time in the last of our weekly sessions, I have a version of this which only has the joints, just that they're just in the correct pivot places, and we're going to think about it and reassemble it from scratch.
That's great, because I think, now we know the ingredients for this, right? Now everything we need to learn now is how to understand these rigs or what needs to be done to make it work. But the basic ingredient is always the same. It's funny, and it's so simple, right? We had a few questions.
Yes, please.
So the first one was from Strange Apprentice. I love that name. Looking forward to this. Can you give tips on how to figure out priorities?
Yes. The tip is whatever executes first needs a lower priority, or needs to be before in the execution tree. Now, that is the basic rule. How do we do that? As I move forward today, I'm going to show you a particular way of setting up a simple robot arm. And I'm going to start with this, which will give you a certain indication of how you can go about doing this. Let me make sure I may have so this is a simple robot. Let me see this. I think this is something where the priority had to change. Okay. And maybe this will give you a better idea when I explain this. Before I go into this, I'm going to let this pin here. Let me see. I have an empty scene, and we won't be seeing this again. Just emptying a bit my multi-scissors. You all know how to do it now. I do have a YouTube video on my channel that shows how to do this using the Pythagoras theorem and so forth. All that is pretty good information, because doing things using math, it's not bad. It's not cheating, right? Everything is cheating. So here we go.
But everything is also math, right?
Internally, internally everything is math. The trick is to get the computer to do it for you. Otherwise, why do we have computers, right?
Right. So, we have another question.
Oh, yeah.
Let me. It's about the start example. Let me just quickly bring it up. if the start example, that was the one that you created with one joint going up and one going to the right, if it would be a real thing, a crane maybe, the first joint would only tilt around one special axis, and the rotation around the other axis would
I'm going to
come
show
from
you.
another joint.
This is what we're talking about. This is it.
Perfect. Yeah.
Okay.
All right.
Yeah.
All right.
So this is we're going to talk about this when we talk about the priorities, but this is one of the typical things where you can see it in the robot as well, where when the goal moves, this pivots around and it doesn't tilt, as I showed with the two joints. So the divide and conquer method I was talking about will become more apparent. What I want to show now, because not many people know this, and it comes down to joints being glorified nulls. Okay, so here's a cube, right? This is by no stretch of the imagination a joint. I'm going to make it editable. I'm going to move the axes down by pressing and holding L. Here's a cube. Let's take another cube, make it a child, and move it up here and tilt it. There we go. And let's take a third one, make it a child, and move it here and rotate it. Okay. Let's go and apply an IK tag to this and see what happens. IK tag, this is the last one. Go to tag, last one, add a goal, and take, did I add the last one? Oh yeah, and I'm going to show you why this looks slightly different. It works. A IK tag does not require joints. No, it can work with any objects. It can work with nulls and so forth. The difference between a joint being a null and the bones being drawn between them is what we're seeing here, that this cube here, you will not see it drawn if you are using joints. So I can always take this. That's how you need to imagine it. That the last one is a little stubby joint. There you go. And here it is. I have my joint chain. It works like any other joint chain, and it does what it needs to do. So in many cases, you don't need joints to do this. Joints are nice because you can see them, you can have them structured, you can separate your geometry motion from your joint chain. So for troubleshooting purposes, if you are familiar with the whole system and the tools, it will make it, for me, it's a better choice. You can change their visibility, you can change their colors and all that without affecting your geometry. But if your goal is just to go and rig something, a stick person or something like that that dances, you don't need joints. That's it, right? But you need joints if you're actually deforming your object using joints, because the skin object will not work. You can't bind anything to an object. You have to bind it to a joint. So, and this is the stuff that a joint will allow you to have. It's how you can skin it to the object, and the different hierarchies here that you can have symmetries and you can have all sorts of other things. But as far as the settings of the IK chain here, everything, including dynamics, can be used as far as I know. Let's see if this is going to work with dynamics. Is it going to work, or does it require? That's a good question. It requires joints. There you go. So we found one more difference. So that in order to use the advanced, will the keep goal work? Yeah, the keep goal works. But in order to use dynamics, it appears you need to have joints, because that's where the dynamics are being calculated. But other than that, it's a glorified null, or you can use the joints are glorified nulls. And if you want to use straightforward kinematics, all you have to do is just make sure that you do the proper hierarchy and you know where the center of their axes is, which is what's going to rotate. And that's pretty much it. Now, that's all about geometry and how to use that with inverse kinematics and constraints and all the other things. Now, let's get on to this problem, because this is a very interesting one. The reason this fails, the way this fails is that the intuitive way to do it is, I want a robot that has a big arm there. So here's my joint. I want this to have a big arm here. And then I want it to have a, overhang, and then the grappler. Okay, fantastic. So let's make this good. And then the next thing is the next point of bad expectations is to go here and say, good, what I'm going to do now is I'm going to put an IK chain because everything is going to be controlled by the IK. So go to, oh, I have it here. And let's go to IK. Let's drag the last one in. As Noseman says, let's add a goal. Now let's move this around. I'm going to move it up, just like Noseman says, move it around. All right. What am I going to do now to fix this? You can't. That's it. The way the IK resolves requires that certain angles are kept intact. Now you can say, oh, you know, I'm going to use a restriction, sorry, a protection tag. Hey, I only want this rotation. Nope. It sort of works, but it's not bending downwards, right? It doesn't go back downwards. Look at that. So we achieved one of our goals to fix it there, but now the rest is not bending. And that's because the way the IK resolves requires the other one to bend properly. To bend, when I say properly, to do this sort of motion. So it can propagate the proper rotation to this. All rotations occur in the red one, as you can see. That's where they occur. And it doesn't matter where I put this, it will always have all my joints sort of aligned. They're going to tilt this way and they're going to tilt that way. So how do we fix this problem? Well, we divide and we conquer. So let's try this again. I'm going to go to a blank scene. So the arm on top, we go back to this and we say, here's my joint at the top. That's the one that's going to be IK. I'm going to do this and I'm going to do my tip, right? So here's my joint chain, add the root. Noseman said it, root. Let's do that. And let's go and add our IK chain here. So IK, do that, put the last one here and add a goal. So what I've created now is the overhang, right? And here's some good practice, right? Let's start with good practices. Select all the objects and go to your coordinates and freeze all transformations. The reason for that is that you can see, although these ones, the first one, because I made it a child of the root, I made the root a parent of that, has zeroed out coordinates, but everything else has some sort of coordinate here. By freezing a coordinate, it's like putting it under an invisible null. So just like this one has a position in space, but because this is a child and it's in the same place, it has 0. That's because we put it in a null. By freezing all your coordinates, you're putting them under this invisible little null, and everything becomes 0. That way, you can just go and zero out your defaults. They're all 0. And you can bring them back to where they were. And when you want to see the actual coordinates, it's the unfrozen coordinates. So freezing is always a good practice when you want to have things in the right place. So now what this is doing is moving that. Okay, this is my crane. What I want to do now is I have a base on my crane. This is a very intricate model of the base of a crane or a robot. Right? This is 22nd century model. Right? And what I want to do with this is, because this is a structure that's holding the whole robot up, and you know something, I'm going to make it even have a big thing here like that, because modeling is so hard. Look at that. If that's not the most intricate crane you've ever seen. What I want to do here is I want this to rotate and allow this crane to go left and right. All right. So how do I do this? First of all, I'm going to save this. Let me quickly save this. And I'm going to call it crane 01. Boop. All right. I just saved it quickly. So this is not going to be part of your rig here. It doesn't need to be part of the rig. As long as when I pull this over here, this rotates with it, then my mission is complete. I don't need to do anything else, do I? So let's go and do that. I'm going to say, let's put this out here and let's see how we can make this work. There are 2 ways to make this work. And it's somewhere It's these two examples here, where I have a null that's moving left and right. One is with a target and a protection tag, and the other one is with an aim constraint that only constrains the H rotation. So let's go and do both of these so we know what we're doing. Here's my crane. When we use a target tag, we point the Z direction. So let's try with that aim constraint thing. I want to point in this guy's general direction, but without pointing upwards. So go here and say, I want, or we'll go here. I want a constraint that aims towards this goal, but only using the H. So I don't want to constrain the P and the B. And because I never, ever, for the love of anything you feel holy, remember what H, P, and V, P and B is, I always go and do a little rotation here to see which one it is. I want it to rotate this way. Oh yeah, I've got the constraint. That's why it's not going to rotate. Go away, you. There you go. And again, I need to select to see my attributes. It is the H. I'm a genius. So let's go constraint and aim. Only the H. Where do we want it to aim? At this point here. Let's move this and see what happens. Save. There it is. Who cares if they're not connected? And when I say who cares, I mean it. Who cares if they're not connected? This is what you want. And if your axes are in the right positions, everything's going to work properly. There it is. What you're seeing here is how you resolve that particular problem, where your robot arm or your crane rotates where you want it to be. The reason this example is so spectacularly important is because the essence of creating efficient, fast, predictable, and working rigs is not to have, number one, wrong expectations of how the system works, not to try and over-engineer it, as I was fighting with a couple of years ago to do this. I spent days and days because I had that wrongful impression. Divide and conquer is exactly what is required. It's not a shortcut. It's not some sort of luxury. It's the requirement to build these things to work efficiently in the most simple of ways. And that's all you do. And what this is doing, it's saying, well, move these three joints here. And of course, you can put your arms as children or whatnot. And at the same time, aim the Z-axis of this hierarchy towards the general direction of this without pointing upwards. Okay, so let's do the same thing now. I'm going to go here and reset my coordinates of this. Why did it go down there? Didn't I freeze coordinates? Damn you. I must have done something. I must have done something wrong. So I'm going to do a few times, bring it up. There you go. I don't care. So let's do the same thing using the restriction. Now, this is the preferred method because the good thing about this, as opposed to using the protection tag, is that the protection tag doesn't have a priority. It works in its standard priority. So in certain cases, you'd need those priorities to work properly. But I'm going to show the example to show how priorities are very, very important. So let's remove this. What I want to do is, first of all, put a restriction tag. So again, I have them in front of me and I can't see them. There's nothing I can teach you about that. So I always call it restriction tag. When I say restriction, just auto-translate it to protection tag. Okay. So protection tag on here and only activate the H. So the only way this is allowed to rotate is around the H, nothing else. It can't go, right? And it can't move because I told it not to move. If I want it to move, I deselect these and so forth. The second thing I want it to do is aim towards this. So I'm going to use a target tag. And this target tag is going to aim towards this. And now I can move this around and it's going to spin. Now I'm going to undo and press A. Oh, it did work here. So in some cases, and this will be the important thing, the way I want this to work is, first, I want the IK to resolve. And then I would like this to point in this direction. In this particular case, it doesn't make a difference at all. And the reason it doesn't make a difference is because these two setups, the target with the protection tag and the IK, are totally independent. They do not feed off each other. It doesn't, this one will resolve properly despite what this does, and this will resolve properly just using the result of this. In this particular case, let me try this. If I go, so the IK tag is 0, let's set this to minus. So we're going to get this to execute before and see what happens. It still works. Let me undo and undo one more time. Oops, redo, press A, move it, undo, A, nope, nothing happens. And that's because they are both independent. Where you find priorities make a difference is when you have dependencies on each other. Here also, we have another thing. This, because it's above this, it executes first. Let's see if it changes anything. This could be interesting. Move, undo, press A. No, A means refresh. If you don't see when you move something and you undo and you press A and nothing moves, that means there are no priority problems whatsoever. So I can reset this to default. So that doesn't matter. I had a priority issue earlier, which I wanted to show, but it wasn't this one afterwards.
However, what you just mentioned in the fraction of a sentence was a very important concept, and that is that the object manager is being executed from top to bottom.
Yes.
Right. Except for cases where you have hierarchies, then usually it executes the inner parts first from top to bottom, then goes one level up and so on. But in general, it's top to bottom, and the tags are being executed from left to right by default.
Yep.
That's also important to know, because sometimes you don't have to mess with priorities when you have this in mind and set your scene up in a way. Sometimes you really need the priorities to just override the standard execution order in the object manager.
Yeah, priorities can get hairy and will get hairy when you have bidirectional relationships, right? We are going to see some of these. There are some tips and hacks which I am going to show at the third week, which allow you to get a better result even when you have bidirectional relationships, so circular dependencies, because for certain rigs, you cannot get away from a circular dependency, unfortunately. Some of them don't look very elegant, but they actually work. And this is the essence, that we will see a lot of fully stable, 100% stable. This is 100% stable. This will not break because it's working in two different contexts. They don't affect each other. There's a very specific flow. This does its own thing, and then this is driven. Done. There's no discussion about that. But in certain cases and certain complex rigs, you will see that there are bidirectional relationships because there's no other way to do these things. But in those cases, again, I'm going to show you some hacks, some tips how to do that. So this is the robot. This is a combination. What you see here is the essence of this model here. This is all this does. We have this on those joints, 1, 1, and 2. That's it. Then we have somewhere here, this is the bottom part of the object, and this is on a null with all the other things, and you can actually move it left or right, and because this is outside the hierarchy, everything else is going to stay right in its place.
Yeah, that's super cool.
Yeah, it's the same thing as this. Here's my crane. So what I can do now is I can say, okay, let's do this. I'm going to put, what happens if I put my root as a child of this? Well, let's see, because now maybe we're going to have some priority problems because one affects the other. So let me put it here. Let me undo. Yay, we got a fantastic. Because now the recipient object is doing something that affects what preceded it, because this root precedes the other motion. This is a typical case where you want the priorities to be correct. And what we want to tell it in this particular case is, first, to resolve this. So put this at 0, because the target tag by definition is at 10. It assumes that it's going to resolve later. But sorry, in this case, it's the opposite. We want this to resolve first. And the reason is, when this starts rotating, because of this, it affects the base joint, so that when the base IK resolves, it's going to be in a different position than it was when it started. So it sounds counterintuitive, but we need to resolve this first, so that when I move this and I release my mouse button, I want the calculation of the IK, the correction. You can see it is happening, but the final accurate position, I want it to happen when I release the mouse. And when I release the mouse, this joint is rotated here anyway, because it's a child of this. So I want the IK calculation to happen one more time. So let's see how that works. You can either make this less than 0, or you can make this more than 10. I'm going to set this to 11. Before I do that, let's see again what the problem is. You can see there's a bit of jitterness over there. I don't know if it's visible on the stream, and that's because it's calculating the end position of the joints with a lag. And again,
maybe it's more visible when you type something into the numerical input fields to make a bigger make it a bigger difference.
Move this. Well,
Not
the
just
best thing is to undo. Undo. Look at that. Press A. Goes there.
Yeah.
It shouldn't do that. So let's go to this and tell it to have a priority of one more than this. Just one more. That's all you need. 11. And let's try it again. Move it. Undo. It's in place. Press A. Nothing happens. So this was a perfect example of a system that, although works fine without making that child-parent relationship, if you do it because maybe you want to do it or it's necessary for your setup, then we have the typical case where the joints are affecting the cube, because the joint goal has to be followed by the cube, and the cube then affects the joints. This is a typical example of a cycle where it's a feedback loop, essentially. And the system resolves it nice. In most cases, if you animate this, you won't be able to see many problems. Maybe if it's a very fast motion, you'll see a bit of stuttering or some things out of place. But the correct way to do it is, say, either build the hierarchy in a way that the objects don't affect each other. And this is the great thing about the divide and conquer method. The target tag with the protection tag that's rotating our column is providing the correct rotation we need. And the joint goal that is moving and rotating our base joint, because that's how IK works, is still providing us with a correct rotation. So unless it's absolutely necessary for other reasons, you should never have to deal with priorities in this particular case. But if for whatever reason you need to do that, for whatever reason, or you want to mess with your colleagues, I always say this in every stream, messing with your colleagues is a very good reason to do these things, right? Makes you look good and smart. You can solve the problems and all that, and it's fun.
In the end, it helps the team, because in the end, everyone will know. We have a few questions on priorities. So, well, actually, I have a question about priorities. I know the answer, but so maybe we can explain priorities a little bit more from the ground up. There was one question by Storgo. Does the priority type make a difference?
No. No. So, did you know
execution order.
Did you know that? Oh, you didn't? No. So internally, all priorities are just numbers. These names here just indicate 1,000, a measure of 1,000th. So initial is 0 to 1,000. Animation is 1,001 to 2,000. Expression is 2,001 to 3,000. But if you use the names, that is not required. You actually go there and go from minus 499 to plus 499. So minus 500 plus 500. But you can even keep this, if you want this priority to execute before animation, you can set this to, I don't know how much. Can you do the minus? No, it clamps it here. So now I understand.
The minimum and the maximum.
Yeah. It clamps it because you're using the names, but internally, and it's actually in the help. That's the funny thing. It is in the help. It has these sort of things here. Does it say the 5,000 thing? It doesn't. Nah. So yeah, the type just transpons this by 1,000. That's all it does internally, but it's named instead. The system works that way. Yeah, I hadn't tried it beyond 499, and I always thought, you can push it, but you are right in the sense that you cannot go further down because that doesn't allow you to go before 499. But if you go to animation plus 499, that's just a couple more priorities before this one.
Yeah, the key takeaway here is that lower numbers are numbers that are going to be executed earlier.
Yep.
And later numbers are numbers that are going to be executed later. Usually, everything that every expression that you create has a priority of 0, except for some that are more like expected to be executed later, like the target expression, I think, has a priority of 10 by default, right?
Yes.
Yeah, here we go. So one tip that I can give you, especially when you are trying to create like more complicated setups, is to not just go with priorities of let's say -10, -9, -8, but always do increments of 10, because then in case you want to add something and it needs some priority in between, let's say -20 and -10, you have the space to do that. Yeah, that would be like I learned it the hard way thing. And then I had to go through all the priorities again. So I always do increments of 10, and then when I have something that needs to be executed, like in between two expressions, I just have enough numbers to make it work. And Can Erduman is here and has the same tip, actually. So that's cool, because Can is doing a lot of rigging. Hey, Can, good to have you here. Yeah, especially with character rigs and so on, this can really save your life.
Oh yeah. What I would say on top of this is that don't only don't build your rigs willy-nilly expecting them to work if you go and start playing around. Because one problem with the priorities is that you can only see them, that we don't have a priority manager. You'll only see them if you select the object. So when you're building something, the tip that Jonas and Jean just gave, to make sure that if you are building something and you are using priorities, space them out so you can put things in between. You have 1,000 numbers here, right? 998, sorry. And it's quite a bit. Don't be, you're not saving anything by using smaller increments. So that's number one. Number two, when you're building your rig, if you can build it in a way where the natural flow of your object manager defines how things are going to execute, then choose that. In this particular case, this is going to execute before this, which means that if I make them both 10, this should work. I'm making an assumption here. Do that, say undo, and it works. So they have the same priority, but because this is going to execute before this, because of its place in the object manager, then you can get away with this. But making your setups have a logical flow. Don't rush to build them. Always make sure that if you can divide, you divide. Don't put that complex 1, 2, 3, 4 and expect to do things. When you have a complex mechanism, and I think the whole series is how to simplify very complex mechanisms in pretty much 3 joints for each and every specific mechanical motion. And then you define how you want that to move. You can put a null above it, make that point somewhere else or move somewhere else, and so forth. And there's no, it doesn't cost, you don't pay extra to use nulls. That is something you need to remember. Here, you can see how many extra nulls I have. I didn't get charged by anyone for that to happen. So it's good to work with extra controllers, turn on your various shapes, make them bigger so you know what they're doing. This one points in a direction. That's why I want it this way. This triangle moves things left and right. Whereas that over here, the mover, no, I have actually the hexagon. But all these things make a huge difference when you're building a very specific and complex rig. What other questions do you have? Oh, Web Mobilized says, does...
Oh, I was muted. So yeah, I just wanted to bring that up. Does the target tag align on the Z-axis only?
Yes. As far as I know, I haven't seen anything else. It aligns only the Z-axis. There's no choice to select anything.
The target tag only allows you to do that. If you want objects to point onto other objects using another axis, then you would have to go with the constraint tag. The constraint tag also has an option for is it called target?
Yeah, the aim constraint.
Aim constraint, exactly. And with the aim constraint, you can choose the axis.
And,
there you go.
Again, choose the axis, and we can do the same thing. And now let's see. This one is gonna. So we want this one to execute first. Currently, it's 0. This one is 10. If this was 0 as well, it would work because it will work because they're both in the proper hierarchical execution. This one first, this one second. But if I wanted this one to execute before, I'm going to create a lag situation now. Undo, and there it is, the lag. Press A, and you can see it. So this is all you need to remember about priorities. So let's put this back here. But yeah, as Jonas said, the aim constraint does exactly what the target tag does, plus a few more things. And you can choose which axes you want to aim. You can aim the X, you can aim Y, whatever.
And if I'm not mistaken, because there is an add and remove, you can even like transition between aiming to one object and aiming to another object. That's always a quite cool thing that you can do with constraints, that you have these blending options.
And yeah, you can go back and forth and so forth. If you have 2 fixed points, that will be a way to rig this. Now, this actually brings up one of the things I wanted to talk about, which is control. Now, this is straightforward. It moves, it does what it has to do, and so forth. But sometimes we want this to do a very specific predefined motion from one point to another point. And there is no shortage of ways you can do that. So you can set up 2 nulls, and this, I'm going to expand on what Jonas just said. So I'm going to make one null. I'm going to make a null in the same position as this. I'm going to make a copy of this null over here, right? So I have these 2 new nulls. I'm going to name them 1 and 2 for start and end. And what you could do is you can tell this. Let's go and see them. I love these little gizmos. So I'm going to make this a sphere. What you would do in this particular case is you would tell this to have again, it's open and I keep forgetting it. I want a transform tag, and I want it only for position. And I'm going to add 2. I'm going to add 1 here. I'm going to add 2 here. And you can see it goes in between. That's because it blends these 2 numbers. It actually adds them up, normalizes them, and finds the ratio. But this way, you can say, I want to go here, or I want to go here. So this will be one way of doing it. Let's find another way of doing it. Let's remove this. I'm going to select these 2 and say, I'm going to create a tracer from these 2. So I'm going to create a line by connecting all objects. And then I'm going to tell this guy, why don't you go and align to spline on this spline here? Now I got 1 and 2. And if I move any of these, I can move it further away. I can do this. I can put this on a user data of something else. I can connect that to a lever here, which I pull, or lever, pull it up and down. The way you will control things is so unbounded. It has so many different ways of doing it that it makes absolutely no sense for me to sit down and just start making these kind of controls. You can make GUI elements that an XPRESSO that tell this to move on the x-axis from here to here. You can do whatever you want. You can put this on a circle, align splines. You can do all sorts of things with this. But before you start rigging something, as I said, it's very, very important. You have to define what your preferred way of moving things or controlling your rig are going to be. That's one of the most important things because it's going to define how your rig is going to operate.
Yeah,
So
we had this question earlier. Well, I don't know what the question was again exactly, but it was something like, couldn't this be built with XPRESSO as well?
yes, it can, right.
And the answer is yes. There are always multiple ways of creating something. I think that what Noseman just showed is the easiest and most visual way of creating something. But of course, you can create crazy XPRESSO setups and so on. You can program it with Python. There are many ways. Many of these setups can even be solved or created using MoGraph. There are always a ton of ways of doing it. But that's the cool thing in Cinema 4D, in my opinion at least, that there are always multiple ways of achieving the same result. And if you know all of them, you also know of the advantages and disadvantages of all the ones. And depending on the situation that you are in, whether it should be like animated or the way it is going to be animated in the end, you would pick either this way or the other way and just make an informed decision.
So it's, where I need to show one more thing, which will, so preface, I didn't realize we were overrun by 25 minutes. Good.
Yes.
And what I'd like to show you is very quickly a setup like this. How do you define how you're going to rig it? And it's not all that difficult to do. Okay. So you can see I've mixed everything here, double. So now I'm going to go in that unfortunate situation where I didn't build it in the most efficient way. I'm going to give you a quick overview of how you would go about building this. Let's see what's here in the bottom right. Joint goal. I don't care. And I've just got the various elements. 1, 2, 3, 4, and 5. Whoops. Go away. Go away, go away. I can always open this, go to tags, and delete all my constraint tags and all my protection tags. And I only have polygons, nulls, and all that. So how do you very quickly begin doing this? Well, in this particular case, what is most important is the pivot points, because that's where my joints are going to be. So I think I've named, they're called rivets. So let's try and find all our rivets. Rivet. There you go. And is it Control Shift or Alt Shift? Yep, it's created nulls everywhere. Let me close this. I think it's created nulls everywhere. There you go. Here are all my nulls. Cut and paste them. There you go. So these are all my nulls here. I'm going to move them out of the way. I pressed Alt Shift and the selection is going to make children of these. Now there's a command here, I think, that says convert to, is it convert to, where is that character? Convert to joints. So now I have all these joints, I can get rid of my nulls. So here are my joints, and they're all placed on the correct pivots, as you can see, where my pivots are. So the question now becomes, okay, what are the fixed points here? Is this fixed to a wall and these just move willy-nilly? Or are these two fixed to, I don't know, a pillow and the rest opens up? And I don't know what the answer is. I assumed that this one and this one are the ones that are pinned, right? So this one here, I'm going to call it P for pinned up. and this one here is P down, P bottom. I'm just going to put it here. So now that we have these two, and you can always go to your side view over here if it's easier for you to see, which is not in this particular case. Now, if you're wondering why they're offset, it's because this is a two-dimensional rig, so it doesn't matter. When I constrain these, retaining the distances, it doesn't really matter. It doesn't flex or twist in any direction. Now, my question here now is, okay, what do I rig to what now? And we need to find those triangles. We have the base here, and the natural next joint for this one is this one over here. All right, so this will be the middle of the next one. So for the bottom one, this should be the 1. Now, before I move forward, let's talk about this. This one here, right? We have this one over here. Where is its sort of natural motion? Well, let's think about it for a moment. This joint here, you may assume that it's over here, right? You may assume that. But if we go all the way to the end and say, okay, let's talk about these two. These two require 2 points of motion. And the 2 points of motion would be this one, and this one. So when I move this, it goes downwards. When I move that, it goes upwards. So if I make a joint using this one over here, 1, and this is the, I'll call it 1, 2, this is 2, and 3, this is 3. So this is my joint chain over here. I'm going to turn this off. Let's see what's left here for this to work. We have 1, 2 of these joints. We need a third one, which will connect to the other ones. And we have 1, 2, and a third one. So this sort of becomes a bit of a conundrum. Well, which, how do I stitch these together? But all the information is still in front of us. There's nothing missing here. And if you go and you see let me close everything I don't need. So the robot closes the double. This is the one we're working on. Let me save this. Let me quickly save it and as 99999 and open up the same one. The simple robot scissors. Which one was it? Double trapezoid assembly? No, I forgot what it's called. Crossover. Double crossover assembly. Unable to open file. Why? Because I changed the name. I changed the names quickly. So 1 double crossover assembly rig. There you go. Let's take a look at the 3D view over here. What you're seeing is that this one is going to attach over here. This one is going to attach over here. We only have 2 joint rigs, right? That seems odd because we would think that we need a third one. And here is where the clamp constraint comes in. Let me show you what I mean. So where's 999? So we know we have the last one, the defined one over here. There's no question about this. The other one over here, I'm actually going to do the following thing. I'm going to say this one here starts from here, goes here, and I have the next one over here, these two. All right? So this is going to be my main assembly. And let's go and create the IK for this one. And let's go here and drag the last one and add a goal. Oh, I did the opposite way around because I made a mistake. So let's delete this and put them the other way around. I want this one to be the, oh, no, what did I do? Main. I think I dropped the wrong IK tag in there. So IK, drag the last one. There we go. I made a mistake and dragged the wrong one. Add a goal. And here's my goal. Add my goal. move. There you go. Yeah, I was clicking other things. So this is what we want over here. As far as how this is going to move, at least as far as this part, this needs to be parented to this, because depending on where this moves, I want that to move with the rotation of this one over here. Which one is that? That's this point over here. So you can go and you can say, okay, let me bring it down because it's going to resolve after that. So this is going to resolve after that. And what I can do here, well, I want a parent constraint, which it's the same as parenting it here, to make sure that I don't intertwine my various joints here. And I'm going to parent it to this one because this is the one that's providing the rotation when this moves, right? So let's go here and add a parent constraint, rigging constraint. Let's go add a parent constraint. And in that parent constraint, I'm going to drag this one over here. Let's see if this is going to work. There you go. So you can see it's working nicely. The problem here, the only problem we have in this particular situation, and if I start putting these where they need to be, so I can put this, it's number 1, so I can put this in number 1, and you will see that it's going to move with that. I can put this in the whole bracket here. I can put it, I think it's this one here. Yep. So this one, I lost it again. Yeah, this one into this one. There you go. And you continue going down there, down that that road. Now let's talk about this.
And you continue undoing. That's also, in this case, you saw how important it is to really get back to that initial position of everything. That's
I think I did something and I broke it. What did I do? Now one goal. No, that's not the one I need to move.
No, didn't you have 2 goals in there at some point?
I made a copy of it by mistake.
Yeah.
I pressed copy paste instead of Control Z. Who does that? So again, as I'm parenting these over here, I'm just putting them in. Again, you can go here to this, the bottom over here, and you can add a parent constraint. So constraint, parent, and select this joint. So again, it's going to work in the similar way. So you can choose how to create these relationships. Now let's talk about this. This here, what defines the motion of this is not it's not joint. It doesn't bend anywhere. The only thing we need to do now is make sure that this one rotates in an angle and retains the distance, the distance between this and this. You know, this is pinned here. It can only rotate around that pin. We know that a circle has the radius is constant. It doesn't matter where you go. That's what defines a circle. So if I just tell this point to find a specific way to always be at the same distance from this, and this is the PU, then this should work, right? Because now we can bring it closer and it breaks the rig, or we can pull it away and it breaks the rig. We should only be able to move it in a direction that retains that sort of that radius. So I'm going to tell this to get a very helpful constraint called the clamp. And the clamp, what it does, it records the distance of something. And let's see how this is going to resolve now. There you go. See that red line? Look at that red line. And at the same time, I want this to always point in that direction, because now we're keeping the distance. There you go. Our rig is working. But we need something to make this always point here. And currently, you can see the joint PU is not rotating because the clamp doesn't do that. Well, we can always tell PU to aim using another constraint. So go constraint and tell it to aim at what? Well, I want it to aim at this all the time. So let's go and pick this one over here. Let's try it one more time. So it is rotating there. So let's take, let's see, is it rotating? I want to make sure. You can see it's rotating. You can see that little icon over there. And now
it is rotating.
Since it's rotating, I'm going to take this and I'm going to make sure that this bracket over here is either a child or I use my parent constraint. Good. And last but not least, I will constrain this to the rotation of whatever I'm is taking care of these rotations. And that could be make it a child of this null, or use a parent constraint and put it there. We do have a lag. I'm not going to deal with priorities in this particular case, but I have to think about, okay, when is this executing? Is it executing? Does it need to execute after? Does it need to execute before? And so forth. It's the typical undo, press A. See, now it's not lagging anymore. I just made this. I didn't even think about it. I made an educated guess. It either needs to resolve a bit later or a bit earlier. If it didn't work, I would actually take it into the negatives. And let's get the last one here. Let's say this, and let's, I'm going to try a parent constraint. And let's go rigging, constrained, and I need to parent it to the PU. So a parent constraint, if it breaks, I apologize, we're going to end the show on a broken setup. I'm going to share these scenes if you wish anyway. So let's put this here. And let's try it one more time. Move this. Oh, what did I do? Oh, yeah, local. So in some cases, you may need to where the local offsets. Somewhere my local. No, actually, I'm not going to do that. I'm actually going to do a tag constraint, target constraint, rigging tags, constraint, transform constraint. Let's try this and watch this button, maintain original. It's under the offsets. If I don't click this, this will jump where this is. What I want to do is maintain the originals and only do rotations. Do you think it's going to work, Jonas? Or am I going to break it?
It's you're going to break it.
Because I didn't click maintain originals. Let's see now. Is correctly. Well, the joint is moving properly.
Yeah.
Yeah. Just look at the joints. In any case, these files, I don't think it's moving properly, but let's find it here. Let's go and find my. I'm going to share these files anyway. I'm going to put them in a Dropbox so you can take a look at them.
It's good that you mention it, because that was a question that we had on the chat as well.
Yeah, and I need to do these without talking too much. And everything you see here is just based on the same principles.
Yeah.
Just on the same principles. Nothing. You see constraints that constrain things in the correct positions. Some of them have offsets, some of them don't have offsets, and so forth. And it's just recycling the correct things at, in the correct orders. And this particular one here, which is the final, how did I put that? I used the target tag. Look at me. I used, see, a different way to do this. I want to show this. I do need to show this. So instead of, which one exactly was that? So in terms of this PU up here, instead of doing the aim constraint, as you saw, I made sure that the z-axis is pointing downwards. And in my case, I just used a target tag to point to this little thing over here. So there's always, different ways of doing things. But in any case, these are the fundamental things. You don't require everything else we're going to do in the next week is going to be based on the stuff we saw in this week's lesson. That's what we're going to reuse.
So the key takeaway is for these kind of setups, you need to make sure that they are like in a 2D plane. That's an important one. That
Yes.
you know how an IK setup works with just 3 joints, and then how to use constraint tags to link these IK setups up with other IK setups. And in some cases, it does help if you know how priorities work, but that highly depends on the setup.
It's necessary knowledge. You need to know.
It is.
How
It
the
is. At some
priorities
point,
work.
it is definitely. Yeah.
Yeah. Especially as you're learning the system, because you are going to start putting various things together. It all starts from willy-nilly. That's the unfortunate truth. And then you will get to that stage where you're going to be more thoughtful about where to place specific things to do certain things. Now, here's one thing you need to be always aware of. I've put a protection tag on this. And the reason is that I broke this a million times when I was fixing it. Because if you don't have the protection tag, if you're on your side view or use the proper axes, everything works fine. The minute I move it off its axes, it will break the setup. I can start moving it here, and you can see we're getting intersections now. Look at that. We're getting that intersection. So make sure you protect yourselves from these things. And if you're on the side view, if you go to your side view here and you set to default, you can see that maybe you don't catch that. Now my null is off. It's not on the proper axis. So I just broke the whole rig. By protecting yourselves and putting that extra protection tag, that's why there's no way for me to move it in any other plane other than the X, Y plane. So that's another important thing, because if you break your rig, then it's going to be a very, a terrible experience trying to reset everything and put them in the right positions. And I have no idea how much stuff you've built onto that.
Yeah, one more thing that I would give out as a tip is actually to freeze transforms. That's always helping, because then you could just do a reset transform and everything would be in the correct place again. If you could show that.
Select all, freeze all.
Yeah. So in the coordinates tab of each and every object, there is a freeze transform section. And this is there to freeze all. And what it will basically do, it will take the coordinates that are in the transform section and write it into the freeze transform section, so that the transform coordinates are all at 0, or the scales are at 1. And then when you do a reset transform, it will be reset to the 0 coordinates of the transform. And that's this way you can completely reset everything.
Yeah, one thing you shouldn't do is do a freeze transform after you've set everything up. If I go to this nice working setup and I select everything and I freeze all, it may not work again properly, because now some of the rotations were defining. Yeah, so be very careful. Do your freeze transforms when you are in the the final state where you want your beginning state to be, and then freeze the transforms before you start adding your various tags, just to make sure that nothing happens, especially with protection.
Yes.
Yeah. Yeah. Can this rig be cloned? Right. Let's try that. Saved. Let's take, now, if you want to clone it, put it all under the null. Don't try that in other places. Don't try that in the root. Let's take this and put it here. Let's rotate it. Let's move it. Let's rotate it a bit more. And let's go here now with my protection tag and see if it works. Oh, in my 2D view. Let's go here, rotate it, and see. Still works. There you go. Does it work properly? Yep, nothing twists. So put it all under the null. And when you say cloned, you mean using a cloner? I guess so.
So what you just showed is pretty important. That whenever you have a setup that is working and it's grouped under a null, you can just create a copy of it and it will still work.
Let's see. It should work. Beep, 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 beep. Yeah, it works. Sorry, got carried away.
That happens.
Sandro is speaking. Sandro in the house. Freeze transforms and align joins. Let's show this. Sandro Sanakoti. Freeze transforms and align joints are both crucial while setting up any rigging tags and dependencies. Always a multivariable equation. Yes, sir. That's all I have to say. Exactly.
All right. So let me just bring up one last question here. And that was this one here, pretty much from the beginning. Are you going to show gear linking and expressions at some point as well?
I wasn't planning on doing it because it's fairly rudimentary to do that. It's
So here's my suggestion. We will have an Ask the Trainer live stream, not this Thursday, but next Thursday the 14th, and we can show a cool setup there.
Yeah, it will take less than 5 minutes to explain the concept of gears.
That's true.
Yeah, especially
when I build the setup, it will take half an hour, but then it's super flexible.
Well, using the cogwheel, if you use the cogwheel primitive that gives you the various parameters, you can automate the whole thing to a very good extent because gear rotation just has to do with the ratio of the T's.
That's what I want to show.
All right. Jonas is going to show it. Okay. That's a secret. Don't tell anyone.
Yeah, don't tell anyone. Oh, yes. Tell everybody.
Yeah. Okay. So, yeah, Jonas is going to show that. There you go. No question goes unanswered unless it's the one I didn't read.
No, I think we pretty much...
Yeah, for character, Blake is asking about picking up things and putting them in places. I think there were some good tutorials about the parent constraint on the old Cineversity, cineversity.com by Brett Bays, or who was it that did, could it be Darren? Someone did a tutorial that shows, anyway, that how to pass objects from one to the other.
I shared a link in the chat. I also added a quick tip or recorded a quick tip on exactly that.
Mm-hmm.
So I shared the link, I think 2 times.
Fantastic.
In the chat. I can share it again. Let me find it up and maybe we can wrap up as I find the thing. I'm going to paste the link in a second again.
Okay, let's put our beautiful faces up here. There we go. So anyway, you can ask your questions. If you have any simplified files, you can send them on Twixer at NosemanGR. No third-party plugins, please. No production scenes, no textures or anything like that. Simplified to the lowest level possible. And ask your questions. Paste images as well. And if there's something I can do, I pretty much get back and reply to everyone. And if there are any questions about this, it's for this session, save it for the next one. We're going to have in a week, and the Ask the Trainer sessions, right? Those are the best place to ask these questions because we always like to address them in between. But I hope you found some of these things helpful, and I hope that everyone learned at least one thing. If anyone didn't learn a single thing, let me know. Oh, and
it's quiet. Everybody learned something. That's good.
I'm glad. I'm gonna pack up some of any files that I did that don't contain proprietary models, like the things I did. I'm actually gonna post a Dropbox link on my Twitter. So at NosemanGR, go check it out. I'm gonna have a Dropbox link, which I need to write it down, otherwise I'm gonna forget. Dropbox link to project files. There we go. Everything happens live. Who's going to do the closing?
You did the opening, Ellie. Are you going to do the closing? Do you still have the sites all open?
I do. Give me 2 seconds
Woo-hoo.
to just show my screen. Window. Here we go. Share. Cool.
Yay.
Yeah. So
Yay.
just as a quick reminder, if you want to see all the other events that we have going on, so in person and on our lovely streams, then you can head over to our Maxon events page. And as always, everything gets recorded and timestamped thanks to Dr. Sassy. So you can always head over to our Maxon Training Team YouTube channel. And if you want to learn anything new, you can head over to the Nulls University, or as Noseman said, there's a bunch of great tutorials on the old University or Legacy University, which is cineversity.com, right? Or .net, I think. And then if you want to get certified or test your knowledge in Cinema 4D, then you can head over to certification. And finally, as a thank you for being part of our wonderful community, you can grab yourselves a free t-shirt. All you have to do is pay for shipping, which will vary depending on where you live. And then the passcode for that should also be with the link in the chat, which is Maxon Rigging. And Noseman, I just want to say this has been such a great session. I feel like rigging's not something that I'm very experienced in, and the way you explained it just makes it seem far easier than I used to be scared of it.
Good. I'm going to send you a model so you can rig it.
to test me.
Oh, yeah, of course. Yeah. If you make compliments, you have to stand behind them.
Send over.
Oh, I want to thank everyone for attending today. My friend Roman, yeah, well, I know that's why I said it can take us years to cover the whole thing. Whether we're going to do tutorials, yeah, all these are subjects for tutorials in the never-ending list of tutorials to be. Whether we're going to get models from car manufacturers, that's a different story altogether. That's what I have to say.
And it's true.
It's
not to say it's unlikely. However, so yeah, I hope everyone had a great time. I did. And
thank you very much.
See you
thank
next
you very
time,
much
everyone.
for coming. Have a great afternoon.
Bye, everyone.
Or morning.
Thanks for being here.
Or evening.